Hello, my teacher. I am Furkan Bekar. I will present you our Earthcube project that we prepared with my friend Erkin. Our aim is to predict Earthcubes and thus to provide the most optimized urban transformation to contribute to the economy and to reduce the loss of life and property. We prepared the dataset we used ourselves. First, we received the data in TXT format from Kandilli Observatory. Then we opened the TXT file we downloaded with Excel and converted it to CSV file format. In the TXT file, we only took the year part in the time part. There are values calculated with different formulas expressing the magnitude of the Earthcube. For example, XM, MD, ML, MV. That is, almost all of them are the same value. Some rows do not have some values calculated by formulas. We wrote a special script with Python to collect the Earthcube magnitude in a single column to avoid any corruption in the dataset as a MV. We prefer to remove some unnecessary columns in the TXT file we downloaded. Comma was used in float type values, and this was causing an error in the Python language. That's why we wrote a function to replace commas with dots. Now I want to talk about the notebook we prepared for you. We thought to study Earthcubes. We wondered what the Earthcube was telling us by visualizing the data, and at the same time we aim to create a machine learning model that can predict Earthcubes, and we achieved what we wanted. In the notebook, you first see our introduction sentence and the plan of our content. Then we uploaded and checked the data. Then we explained our variables one by one and grouped them as categorical and numerical. Then we did a simple data analysis. When we examine relationship between depth and size, we observed that large Earthcubes are shallow Earthcubes. In this section, you see the numbers of Earthcubes with magnitudes of the Earthcube more than 6 and 7, and this is a number that cannot be underestimated. Then we wrote a function to detect the outliers, and with this function we remove the outliers. The method we use here is called IQR. Then we found the missing values and removed them. Since we prepared the data set ourselves, there was no missing value anyway. Then we moved to the visualization step to understand what the data set we have means. We search for answers to some questions here. We can list some of these questions as follows. We simulated the distribution of earthquakes by years. This shows us that there have been more earthquakes recently than before. When we examine the location of all earthquakes afterwards, it shows us that the most earthquakes occurred in the Mediterranean and Aegean coast. We simulated the distribution of earthquakes. Then we examined if there is a relationship between year and MV. Then we examined if there is a relationship between depth and size. The graphs we created after that showed us that the earthquakes in our country are shallow earthquakes, and therefore the destructive effects or earthquakes are very high. Then in the feature engineering step, we took the necessary steps to create the model slowly. We converted the columns required by us and discarded unnecessary columns. As the last step, we created our model with many classification algorithms and achieved good results. Decision tree results is excellent. Neighbors classifier accuracy. Gaussian naive accuracy. And logistic regression accuracy. It has an accuracy of over than %95 in the 4 models we created. These numbers are really amazing, but there is such a model among them that model is absolutely perfect. The best model is for us is the decision tree, because accuracy is 100. Thank you for listening to me.